Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about MLP Classifier. Even before I proceed to demonstrate how the MLP Classifier works in STATCRAFT, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question. What exactly is the MLP? MLP stands for multi-layer perceptron. It's a supervised learning technique. Typically, a MLP can handle both classification as well as regression-based problems. How is this different from a typical logistic regression model? It is different from a logistic regression model in that between the input and the output layer, there can be one or more non-linear layers which are called as the hidden layers. So this is one of the major differences between a logistic regression model and a typical MLP classifier. There are many advantages of using a MLP classifier. The first advantage is that it has the capability to learn nonlinear patterns from the data. An MLP classifier is widely regarded as a gold standard when it comes to modeling nonlinear data. Secondly, it has the capability to learn models in real time or online learning. Now, let's talk about the disadvantages of the MLP classifier. One major disadvantage of the MLP classifier is that different random weight initialization may lead to different validation accuracy. Secondly, MLP is sensitive to feature scaling. And thirdly, MLP requires tuning. It requires tuning a number of hyperparameters, such as the number of hidden neurons, layers, and iterations. And hence, it is a slightly complex task. Let me now introduce you to the dataset that I'll be working on. This dataset, as you can see, is what is called as the IRIS dataset. It's a very popular dataset which is used in machine learning problems. This dataset has flower characteristics. As you can see here, there are different flower characteristics like sepal length, which is measured in centimeters. You then have sepal width, which is measured in centimeter. Further, you also have petal length and petal width. We will be using these four variables as the input variables. The last variable, namely species, will be used as the target variable. So we will be building a MLP classifier using species as the target variable. The rest of the variables like sepal length, sepal width, petal length, and petal width can be used as the target variable. It helps to have a large data set to train a MLP classifier. Let me now proceed to look at the sample size in this data set. When I scroll to the last row, you can see here, it says 150, which means that there are 150 records in this data set. Further, let me apply a filter on this particular data set. When I apply a filter and proceed to the target variable, let me click on this drop-down menu. You're able to see three different classes of flowers. The first one is setosa, second is versicolor, and the third one is virginica. So our dependent variable has three different classes, and hence this is a multi-class problem. With this background about MLP as well as the dataset, let me now proceed to STATCRAFT. As you can see here, this is how the interface of STATCRAFT looks like. STATCRAFT P is a Make in India initiative. Now, this is a very popular machine learning software. As you can see here, I've already loaded the IRIS dataset into STATCRAFT P. These are some of the variables which we saw in the spreadsheet: flower ID and the different characteristics like sepal length, sepal width, petal length, petal width, and species. You will see how easy it is to build a model in STATCRAFT P. It does not require you to code It is drag and drop technology. All that you need to do is select a few variables under a particular option and then hit OK. Your model results will be ready. In that sense, it saves a lot of time, and you are also not expected to remember the codes behind it. To run a typical MLP classifier, at the top left-hand side, I'll click on the Analysis tab. This will produce the menu which allows me to access the machine learning algorithm. As you can see here, there is an option for machine learning. Let me click on the drop-down menu here. The very first option under machine learning is MLP Classifier. I'll select MLP Classifier. Let me now hit the refresh button. You can see here the MLP Classifier dialog box opens up. In the canvas to the left-hand side, you have all the fields that are present in the data set. To the right side, you can specify the dependent variable as well as the set of independent variables. Which is my dependent variable? The dependent variable here would be species, and the independent variables would be sepal length, sepal width, petal length, and petal width. So at this stage, we have specified our dependent variable as well as the set of independent variables. If you want, you can look at the parameters option. There are different options under the parameter setting. You can see here, there's a very useful option which allows us to specify the number of neurons in the hidden layer. By default, the existing MLP classifier is using 10 neurons in the first hidden layer. It is using 20, 30, 40, so on and so forth. It's entirely under your control. We can go ahead and specify the number of neurons in the hidden layer. Further, for the solution to converge, you can also increase or decrease with the number of max iterations. By default, STATCRAFT is going to use 75% to train the dataset. The balance 25% will be used for testing the dataset. You can change the max epochs as well by specifying a different number. All these are hyperparameter tuning options which we can experiment in the second stage. Let me now click on options. You can see here there are different activation functions like ReLU, identity, logistic, and tannage. The default activation function which STATCRAFT uses is what is called as ReLU activation function. If the accuracy is very low, you can experiment with other activation functions as well. You can also see there are 3 different options under solver. The last of the options that we have is what is called as save. There are 3 items here. The first one is model, second is predicted values, and the last one is predicted probabilities. I will choose the predicted values and predicted probabilities here. Let me go back to the data option and make sure that I've selected all the variables. I have species as the dependent variable. The flower characteristics will act as the independent variables. Once you're satisfied with the selections that you've made, you can go ahead and hit the OK button. STATCRAFT takes a couple of moments to process the analysis. You can see here, this is the output window. STATCRAFT displays the output for MLP classifier. This is the Python code which STATCRAFT has used at the backend to run the MLP classifier. If you want, you can copy this particular Python code and paste it in Jupyter Notebook so that you can carry out some advanced analysis. Let me scroll down. What you're now seeing here is the confusion matrix. This confusion matrix is for 75% of the data. This is for the training data only. It is not for the testing data. One interesting thing about the confusion matrix here is that the diagonal elements represent the correct classification and the off-diagonal elements represent the misclassification. Let's focus on the rows. You can see here, the first species of flower is setosa. This is the actual category. And when you look at the predicted category, it says setosa. So 34 out of 34 setosa flowers have been correctly predicted. Now, let's look at versicolor. There are 42 versicolor flowers. Out of 42 versicolor flowers, 40 versicolor flowers have been correctly classified. Further, you have 36 virginica flowers, and out of 36 virginica flowers, all 36 have been correctly classified. So, except the two misclassification, by and large, the model has been trained appropriately. The confusion matrix is a great tool to understand the performance of the model. Let me scroll down. You can see here the second confusion matrix. This confusion matrix is applicable for the test data. Along the row, you have setosa, and along the column, you have the predicted values. As you can see here, 16 out of 16 setosa flowers have been predicted correctly. There is no misclassification as far as the setosa flowers are concerned. When you look at versicolor, 7 plus 1 would be 8. Out of 8 versicolor flowers in the test data set, 7 of them have been predicted correctly. The last of the flower species is virginica. Out of 14 virginica flowers, 12 of these virginica flowers have been predicted correctly. Looks like the performance of the model is above average. But to get a more accurate picture about the performance of the model, you can also look at what is called as the classification report. This table here represents the classification report for the training data set. You can see here, the first species of flower here is virginica. There are different model diagnostics like precision, recall, and F1 score. F1 score is simply the harmonic mean between the precision and recall. A high value of precision, a high value of recall, and a high value of F1 score is desirable. Typically, if the precision value is greater than 0.7, if the recall value is greater than 0.7, also if the F1 score is greater than 0.7, it indicates that the performance of the model is very good. Let's take a look at the precision of the model in classifying virginica flowers. It's 0.94, clearly greater than 0.7. When you look at the recall value for virginica, it is 1, again greater than 0.7. Let's examine the F1 score. It is 0.97, clearly greater than 0.7. So since the precision, recall, and F1, all the three are greater than 0.7, it means that our model is doing a very good job in classifying the virginica flowers. Now, let's proceed to examine the performance of the model on the training data set. I'm now looking at the performance of the model for setosa flowers. The precision value is 1, the recall value is 1, the F1 score is 1. Now, what does this indicate? Since all the values are greater than 0.7, it means that our model is doing a very good job in identifying the characteristics of the setosa flowers. The last thing that we need to note here is the versicolor flowers. The precision here is 1, the recall value is 0.95, and the F1 score is 0.97. Again, all of these things are on the higher side, and therefore, again, when it comes to the training data set, our model is doing very well in classifying the versicolor flowers. But remember, the real performance of the model is assessed on the test data set, not on the training data set. In the training data set, the results will be slightly optimistic. Let's proceed to look at the classification report for the test data set. Firstly, let's look at Virginica. It is 0.92. The precision value is 0.92. Recall is 0.85 and the F1 score is 0.88. Since all of these three metrics are on the higher side, we can go ahead and conclude that our model performance, even on the test data set for classifying the Virginica flowers, is good. Now let's look at the precision value for Setosa. It is 1. The recall is 1 and the F1 score is 1. It simply means that the model has understood the characteristics and it has learned the characteristics very well, and it is able to very, very efficiently classify and identify Setosa flowers. What is slightly worrying is the precision value for versicolor. It is 0.77. This is slightly on the lower side for this particular model. Let's look at the recall value. It is 0.87. Again, it is on the higher side. F1 score is 0.82, which is again on the higher side. So it looks like our model is slightly struggling as far as precision is concerned for the versicolor flowers are concerned. Now, this gives a fair idea about how is the performance of the model for the training as well as the test data set. As an exercise, if we want, we can go ahead and try to do hyperparameter tuning, but that is for another video. Let me now go to the view button and click on data. STATCRAFT now displays the data set. There are two interesting additions. You can see here the new column, namely predicted underscore values, has been created. The probability value column also has been created. You can compare the actual species of the flower with that of the predicted values. When you look at the first row, the actual species is Setosa. The predicted value is also Setosa, which simply means that the actual is matching with the predicted value, and hence this is a correct classification. We earlier saw that the MLP classifier is highly efficient in identifying Setosa flowers. Let me scroll down. Here you can see the performance of the model as far as identifying versicolor flowers are concerned. This is the actual species of the versicolor. This is the actual species of flower, namely versicolor, and the predicted value is also versicolor. You can look at the predicted probability. It is approximately 99%. I don't see too many misclassifications, not in the first glance at least. You can see here, there is one misclassification. Sorry, this is the one. Versicolor is the actual category, but the model has predicted this as Virginica. So this is a clear misclassification as far as the model is concerned. You can also identify the second misclassification here. The actual flower species is versicolor. The model has predicted this as Virginica. This is a clear misclassification. Let me now move to the second page. This is the second page. Let's take a sample of a couple of cases here to examine the performance of the model. Here we have the Virginica species of flowers. Most of these cases have been correctly predicted as Virginica. Plus, when you look at the probability values, they are on the higher side. So we can be more confident about these results because the predicted probabilities are close to 1. There is one misclassification that I'm able to identify here. You can see the actual species of the flower is Virginica. The predicted species is versicolor. So this is a clear misclassification on the part of the model. So this is how our MLP classifier can be used to classify multi-class problems. With this, I have come to the end of today's video. To summarize the discussion we've had, we've seen what exactly is a multi-layer perceptron. It is widely used to handle nonlinear patterns in the data set. We've also talked about the advantages of a multi-layer perceptron and the disadvantages of building a multi-layer perceptron. Further, we went on to build a multi-layer perceptron using a tool called as STATCRAFT. We obtained a high level of accuracy both on the training as well as on the test dataset. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.